For the final part of the session, I'm delighted to welcome our distinguished panelists for the what promises to be thought-provoking roundtable discussion. Joining us on stage, Professor Abraham and Mr. Chen, along with earlier presenters, Dr. Shi and Professor Jonathan. Let me take a moment to briefly introduce our two distinguished panelists. Professor Abraham is an associate professor and head of architecture program at Technion Faculty of Architecture and Town Planning, specializing in sustainable design and the integration of environmental performance into architecture. He is known for pioneering work in climatic responsive design, combining research, teaching, and developing tools like Ladybug Tool and Honeybee to advance green building practices. Mr. Abraham, Professor Abraham. Who is a founder and CEO of Alpha Sustainable Projects and serves as chairman of the Israeli Green Building Council, a Technion graduate and the lead accredited professional. He has led award-winning net zero energy initiatives and lectures widely on sustainable architecture and construction technologies. Thank you all for being here. So one of the key themes uniting all experts at this roundtable is the use of simulation tools, which are critical instruments that empower architects, urban designers, planners to design environmentally responsive urban built environments. So, Mr. Ken, sorry, sorry, Professor, I can't spell exactly. Sorry for that. Mr. Ken, as both the practitioner and the chairman of Israeli Green Building Council, do you believe Israel is currently leveraging the full potential of simulation tools to advance sustainable urban development? So,
no.
So, what are the obstacles you have observed in this regard?
Okay, where should we start from? There are many things I want to talk to you about. First of all, I think we should frame the context much wider, and sustainability as a global necessity is having a hard time, not only in Israel, but throughout the world. And I think I must say this, first of all, thank you, Jonathan, for organizing this amazing event. For the global challenges, we need the global cooperation, and this is really great. And I think this is something that we should remind ourselves, almost taken for granted, but it's not, that we should really think in a prosperous way, and not to be short-term, as many people today tend to do. Second thing is that emerged in the discussion so far is data, and how much the importance of building data. I'm driving here in the morning with my car. I have all this huge amount of data flowing, and we are in a building, and there is, I think, at this moment, nothing that shows us the performance of the building that we're using. So I think data is really crucial. And another thing, again, looking at the global challenge, is the importance of existing buildings. Because as sexy as it is to design the new buildings, looking into 2040, when all the construction sector has to be zero carbon, 60% of the buildings are standing at the moment. So we need, it's much harder, and it's hard to design with the simulation tools for new buildings, but it's even much more harder to do it for existing buildings. And it also ties in with the lack of data. So our firm in the last years really concentrated on existing buildings. Actually, today is a happy day. We received in the morning news that actually the first zero carbon building was awarded in Givatayim by the Living Future Institute. So it's a 8-story building, office building, which is zero carbon. And why the reason I'm saying it is because, first of all, we had to simulate the embodied carbon of the building, and we actually achieved their 95% carbon embodied carbon reduction. If you ask how we did it or how the building did it, it's an existing building. So again, we see that there is a need to simulate, and now the database of embodied carbon is growing. We do it now for every LEED project that we're certifying, and so this database of embodied carbon in Israel, we're also doing the work with Wachsman Gobelin to go back at buildings that were constructed and check their embodied carbon, their LCA, to learn what typology makes the embodied carbon lower. So this is the great thing. Another interesting item is that the Amot Givatayim, which was certified zero carbon, has a south facade of BIPV. And we have a real-time in my phone, real-time data of how much it's producing. So I think Israel is now starting to have the first, I think, cases of data that we can use more and more to improve our design. So I don't know if I answered the question, but okay, thanks.
Thank you so much, Professor. Actually, you gave the whole insight of what is happening in Israel. And so any panelists have their perspectives on it can also indulge. I'll be going to Professor Abraham, who can give us the architectural education context of Israel. Professor, you're not only shaping the architectural curriculum at Technion, but are also actively contributing to the evaluation of global simulation tools. In your view, is the pace of students' learning rate keeping up with this rapid development of tools?
No.
Okay.
One word, no.
Okay, how can academia better support this alignment?
In more than one word, I think there is not only about the tools, it's about the knowledge of the basics behind the principles behind the tools. And I think sometimes it's more important to understand those things, because one thing that I told the students in my simulation class is garbage in, garbage out. So if you don't understand what you are doing with the tools, maybe the benefit is much lesser than the profit that you can get from the tool. So this is something that you need to take into account. In the building the curriculum, I think we are behind, and I think we are pretty much in the front line with the tools and the methods that we are using. But in the process of integrating the tools inside the practice, inside the studio, I think we have there is a place to improve. And I think that making some changes in the curriculum is important in order to make the use of the tools in a more conscious way that they can improve and impact the design itself. And the students, but not only the students, they need to understand what the tools can make benefit in the design itself. So the question now is more broader that you ask, and not only students and not only curriculum. It's only I'm not sure about what happens elsewhere, but here in our faculty, or I think in Israel, we need also to educate the teachers or the advisors in studio. They don't rely, or they don't think that it is pretty much important to implement those tools, or they ask it's not important at this stage, or it can affect it. Maybe you need to discuss some other issues. So it's like a struggle of how can those things can be more rooted in the teaching practice here, and I think elsewhere, but I think we are going to the right path. I just wanted to add Sam regarding, Jonathan, regarding the carbon and the data. Regarding the data, I think in Israel, it's not only, the problem is not only the lack of data, but also accessibility to data, because there are some things and there is a lot of data that is not accessible. For instance, the electricity consumption for buildings. And this is something that years and years I think we are trying to understand why we don't get access, but the electricity company is not in any way making the trial to see the benefit that the country can get from that. And I think this is something that needs to be changed. And regarding carbon in the simulations, I'm happy also to tell, it's not the question, but happy to tell that that it is happening and research that I'm conducting with the students in collaboration with the civil engineering faculty. And we are already getting results on this regard. It's not only taking into account the carbon. So I think this is something that allows to see the full picture, and I would be happy to discuss it with you.
So now I will open up this panel for a few general questions. These questions are a bit complex or conflicting based on the context, the person between academia and industry. But I think Dr. Shi can better provide us. So are simulation tools enabling collaboration between architects and environmental engineers from your perspective?
It's yes.
Yes.
Yes, I think the CA, why we have CA is we started with energy engineers only. And throughout a few years of process, and I realized we need a designer on the team. And then that's why I was hired. Yeah, so it has been have been using CA as a platform to chat with my colleagues, not chat, exchange with colleagues and engineers, like quite intensively, and make me more like engineers. Right? But when you talk about industry and academics, I think what we're trying to do recently is trying to make a business out of that. It's not because we are trying to make money, it's because if you want to make anything that can be realized in the real world, there should be someone who wants to pay for it. For example, if there's no one, I mean, just now we're talking about people, it's also like who pays for it. If the design firm can allocate some hours to their designers to learn tools like these for a few months, and if someone has to pay for it, it must be some business behind to make things possible. And this is we say this is an obstacle we're having now because we have been promoting this for so many years. Now we put up conversation with, for example, Urban Redevelopment Authority or Singapore like agencies, and we have conversation with big design firms. At first, just no one wants to do the work there, and there's not much clients that who can pay for this. That's something like we as a researcher background now we want to make some real world impact what we're struggling with. Yeah. I don't have to straight about topic a bit, yeah, but it's about industry and academics, how we are relying on these kind of tools in the real world.
And I want to also please, I think the biggest problem is to get the input of the simulation early enough in the design. And there's a tension between making it simple and not making it too simple. So because simulation tools are complicated. And I think the answer is that architects do it themselves and not necessarily get input from the outside, from the architectural firm. And when I was a junior architect at the Diamond & Schmidt in Toronto, my mentor used to tell me, we architects are much more engineers than we think. And I think using during the design concept, simulation tools to optimize the design is something that we don't see enough, I think, in many places, but specifically in Israel. And I think this is something, again, that the new architect should bring into the offices. It will take time. But also something interesting is now Israel has mandated 5281 as a standard, as a green standard. And in order to get the highest level or get the approval, the building permit, actually now there is a necessity to do a simulation at the early stage, preliminary stage. So this, I think, is a huge thing, because now when an architect comes in with a concept and he wants to get the approval to get the permit going, he needs to prove that his building could get the highest level of energy efficiency standard.
Maybe I can add something, is that I have a feeling that you're like running behind a train, which is like accelerating, keeps accelerating. So computation moves so fast that I think that until we educate the next generation, as we must do in order to ask the right questions, AI might catch in. And also, it's already, I think, moving into that kind of completely seamless optimization / energy evaluation / all these kind of things. Also, I see different kind of tools popping up, AI driven, of course. To answer to all the needs we have to supply during the design phase of this kind of evaluations. And if we don't educate you, like the students here, good enough and fast enough, it's out of control. Because how can you control and evaluate the data that you're receiving from the computer? How will you be able to balance it against other things? I always get these questions. Kushagra, thank you for your question. I always get this question, of course, and we want to, harmonize what you show with other things, of course. But if we don't have the human being behind the machine, so we won't be able to do that, unfortunately. Will we do that? Like you want, I probably know what to say.
Okay, I have a question, probably will currently, it's a general question, but for Professor Abraham will answer it. What practical strategies could improve the integration of simulation in both academic and professional workflows?
Prepare for this one. I think we are lucky in these times that the working platforms are becoming more standardized. If I'm talking about BIM. And I think one key thing to make the workflow between practice and engineers should be that they work on the same model, or not necessarily the same software, the same model simulation tools. But I think it's very important that they work on the same modeling platform, because models along the time, years and years and years, make them one of the most difficulties to integrate the joint work. The engineers are used to work with some simulation tools, architects, or maybe if they are using simulation tools at all, they're using a completely different thing. And communicating the model between both practices is a very difficult one. So sometimes that the architect say, okay, I made some simulation, I have this model, and you pass it to the engineer. They usually say, this model is not good for me. I can use it, and I will make the model my model, and giving the feedback from this model again back to the architect is making this practically impossible to make a smooth workflow. So making or using similar platforms, so it's not only simulation tools, but also the modeling platform is very important to have something that can be integrated, or something that can be used for both sides of the practice and the engineering.
Any additional?
Yeah, I can add something. I of course agree definitely with Abraham. It's not at the point where you take a Revit model and you do the energy simulation seamlessly. It still has some problems. But another aspect is to make it again accessible and not expensive. And we recently developed a tool for energy simulation called V-Rate, and it's a plugin for Design Builder. And previously, you had to pay for each run of simulation, and we wanted really to improve the design and to make an impact, and therefore the business model allows you to do as many simulations as possible, and we see people now using it more and more because they don't have to pay for it, they only pay for the license. So what I'm saying is that you, again, looking sustainably, you need to find the also the financial tools that would make it more accessible and more viable in the long run.
Okay, speaking of business model, I think this very good point, following my previous point. Yes, and that's why we made CEA open source at the very beginning. It has always been open source. Everything so far is still open source. But as we are moving things to the cloud, and I know we want to be sustainable to ourselves financially, and we are currently exploring business models behind the CEA. But well, maintaining CEA open source at core. This is a very challenging question that we have been trying to answer in the past 2 years, and we still don't have a very good answer yet. And yeah, so I hope soon we can have a solution for it.
So maybe a concluding remark about this part is that I feel that there are different kind of stars that needs to align in order to allow for that integration. I don't think we're there yet, but the idea that students coming out of this institution, many others, will be armed with knowledge first, but then also tools, and then architecture offices, which will need to shape differently the way they design, and also sometimes the design process. And I see the Israeli real estate sector is really conservative. Would you agree? It's really conservative. So I'm looking at Jakob here with his firm, and I'm thinking about R&D, but I see some hope in R&D departments opening in this kind of far-sighted architecture firms. So I think this is another thing, and then you need the investor to be able to, like the developer, to be able to afford to pay you and to recognize that he or she needs to pay you, and not saying, okay, you want to generate this data, I'll put you in the rubric of this kind of environmentalist that produces the report with other things. I'm not, it makes sense also economically that we don't want to have another, consultant here that we need to feed. But still, it's a sense of what it's a priority, right? So when this becomes a really in high priority, you will see, and also when there is a standard in Israel, it works like that. Well, we will punish you if you don't do something, and that's how you do it. So the standard is something really effective. But if you ask me, and I think you got it from my perspective, working according to standards that not necessarily offer you a great building. And to answer to my perspective, said, oh, but standards are getting better and better. It's not just energy. We have other standards with environmental quality, etc. But still, if we have something in the early stages of the design, thinking about things in the right time with the right tools, that could have, and then bringing you out to the market with an architecture office that supports that, with a client that wants to see that, with the, policymakers in their committees that expect to see this analysis, and maybe they will finance a tool. They will finance a tool because they see, okay, we want every building which comes here to have this analysis of energy and wind and autothermal comfort. And then they will be able to harmonize this thing, this aligning of the stars. We're not there, but we are moving in the right direction, right? In Switzerland, it's maybe easier. We always say here is not Switzerland. We have a saying, here is not Switzerland.
I just wanted to add to Jonathan's comment that if we do the right thing, we don't need standards. And the last thing I want to say, because I think we are closing, is to thanks Jonathan for organizing this thing and to thank the guests for coming here, because it's not granted that at this time we have many guests from abroad. Please, thank you.
If we can take it, because we have some time, we can take because there is an interesting
question.
gap, yeah, there is an interesting gap.
But
What,
Jacob wanted to ask a question.
yeah.
I have a quick question. I'm Jacob from Hellas, so I'm coming up for the academia member for the professional practice. And I see there's a big barrier about the business that architects are paid to do design. We are selling hours and design, we are not paid to do impact. So that is something that we are looking at as architecture industry. How can we change our business model to take more risk on the environmental side? Not being paid for the square meters that we provide, but the carbon that we reduce. Do you see that in Israel? Is there some structure around that how to change business model, how to be inspired by our industries, or just a question for the panel?
Maybe the question goes back to you, because it sounds like you're hinting that you have a different, we were wondering how you are so successful. Maybe it's
But this is something that we are looking into, but just so that you know, that is something that we are looking very much into value-based pricing, that changing our pricing model as architects to get paid by the impact that we do and not the square meters that we provide. So that is something that we are looking into. I had a very low practical question also about the carbon. When you have a new build, how much is in the budget and in the operation over 50 years lifespan? Is it 50-50 or how is this split in Israel?
So, there's a graph, I don't have it in front of me, but if you start measuring the operational carbon, just after occupancy, year one, and you have in year one much higher percentage of the embodied carbon, then they will match, because operationally grows gradually. They will match after about 15 years. Goes to show us that the embodied carbon is huge. It's again, I can give you numbers of ton per square meter. So there are benchmarks for, and also, for instance, for the Future Institute, the benchmark was previously 500 ton per square meter of carbon, embodied carbon, but now they reduced it to 350. And we started checking buildings in Israel if they meet this criteria of 350 tons per square meters. And we actually found there are, even if you build in concrete, but you don't have a basement, you don't have underground parking, you may be in the area of 350. So I'm saying, again, first of all, you need to look at the numbers, of course, and there's not just one single number, but I think 10 years ago, nobody talked about embodied carbon. It was only operational carbon, right? And now we understand the huge impact of embodied. And you know what this generates also is a huge amount of startups, because we're in touch with many startups who are doing low carbon concrete or other kinds of materials. Spirala Tower in Tel Aviv, which is targeting, it's in construction, it's targeting platinum. The envelope is 100% recycled aluminum. When we used to ask manufacturers 5 years ago or 7 years ago to have recycled aluminum in the product, they looked at us as weirdos. But now the market is demanding. So this is really something very important. Awareness will be growing, the demand will also grow, and products will be available more and more.
I feel I have to say just a small thing about that, because I asked myself where exactly these designer is encountering or meeting somebody who comes and tells him, maybe I can do this recyclable aluminum facade, but maybe we can reduce the fully glazing like design of this building. And this is the trade-off that you will get. Then you will get much higher reductions. Same goes for double skin facades, which are now the to-go-to solution when we have fully glazed building because it's so hard. I'm telling you, trust me on that, it's hard. And then why create a problem and then solve it with technology or even with recycling something when we can avoid it. And this composition and compilation of things is exactly something I think we can start talking between us, maybe over lunch.
I see there was a question.
Hey, I'm telling you, let's eat.
Okay, so I see there is no online attendees questions.
And by the way, the credit is not, thank you for so much for the warm words, but the credit is not just for me, of course, for Elam and Naga, but many other people, but I'll say it at the end of this conference. Thank you. And I think let's eat, the food looks great from here.
Okay, thank you to all our speakers for providing safe insights. Thank you so much.